Okay, with relative velocity, here's an example. We have a plane traveling at 400 kilometers per hour. So if it is traveling at 400 kilometers per hour north 60 degrees east, that is v relative. So whenever we're dealing with a plane question or either a displacement or a velocity question, I always recommend drawing a coordinate system here so you can put your sketch on and tell what's going on here. So the plane is traveling 400 kilometers an hour north 60 degrees east. So it's going to look like this. So this is our VREL. So north 60 degrees east. Again, remember we want the angle with the x-axis, so we're interested in the 30. Now the pilot, this is the observer, he set a course 500 kilometers per hour north 30 degrees east. So this will get a little bit messy. So this is my VA. And he set it 30 degrees, which means that we want 60 for him. We want to know what's the velocity of the wind. So from the diagram, you know VA, the pilot took off in that direction, and resultant was he ended up over here. So something has pushed the plane off course, and so I'm predicting that my wind vector, or in this case VB, is going to be pointing in that direction. Now, once you have it set up, we know from previous slide that our relative velocity is equal to VA, plus VB. So VA plus VB. Rearranging it, we're looking for VB. So just using your algebra skills from grade 9, we find out that VB is the relative velocity minus VA. So I'm going to do this algebraically. So relative velocity minus VA is going to equal my VB. All right, so once I have all my angles set with the x-axis, I'm all set to go. So relative velocity, we know that it is a magnitude of 400. And again, positive x, positive y, so it's going to be adding in both cases, or positive. So cos 30 I plus 400 sine 30 j. VA, positive in both x and y component. So 500 cos 60 I plus 500 sine 60j. We're doing subtraction, so my answer would be 400 cos 30 minus 500 cos 60I plus 400 sine 30 minus 500 sine 60j. So there is my wind vector right there. Now I've already predicted that it's going to be in this area here. So I know that my x component will be a positive value, my y component will be negative. So now it's just a matter, remember, when you're looking for the velocity of the wind, that means you have to find both magnitude and direction. So the magnitude of VB is the square root of the information there. Again, you don't have to worry about pulling out the calculator. And, oops, lost control here a little bit. Clean that up. 30 minus the 500 cos 60, that's my x component, and plus, and I'll put the other one underneath here because I'm running out of room, sine 30 minus 500 sine 60 squared. So we've defined our velocity, our angle, tan inverse of the y component, sine 30 minus 500 sine 60 over 400 cos 30 minus 500 cos 60. And the angle is defined, so therefore the wind is magnitude of VB, that's from above, in the direction bracket, I said it's heading east, the angle is defined, and south. So there we go. That solves for our wind velocity. And again, for wind velocity, you need a magnitude and you need a direction. Okay? One last example. A ship steering at that 15 kilometers per hour north, 70 degrees east. So I need a picture here to keep this clear in my own head. So right away, go to my coordinates, northeast, south, west. A ship is steering, so that tells me that's VA. That's the from the captain's perspective. So north, 70 degrees east. So here's my VA, 70 degrees, but I really want the 20. The current is 5 kilometers an hour west, so I face west. I move 10 degrees north, so that is definitely the angle I want. Now this is a factor that's affecting our boat. Determine the relative velocity for someone standing on shore. So we're looking for V relative. So when you look at the formula, we know V relative is equal to VA plus VB. It's going to be from the object itself plus what's acting on the object. So that's straightforward enough. The previous question was a little bit more challenging. When you add those together, you get your relative velocity. So again, make sure your angle is with the x-axis, which it is. So VA, 15 cos 20i, and again, x component and y component are both positive, plus 15 sine 20j. VB, in this case, negative x and a positive y. So it'll be negative 5 cos 10 I plus 5 sine 10j. So that would mean I would have 15 cos 20 plus minus 5 cos 10. So it simplifies to that. Plus 15 sine 20 plus 5 sine 10. That's in the j. So there we go. There is the relative velocity for someone observing from the shoreline. Using a little bit of common sense here, we know that VA is in this direction, that's where we're headed. VB is going to be pushing it that direction. I would anticipate my resultant then is in quadrant 1 because I don't think it's enough to shift it in the opposite direction. So that's going to be helpful. So the magnitude of the relative velocity, so how fast is the boat actually traveling? It's the square root of what we have above. Cos 10 squared plus the 15 sine 20 plus 5 sine 10. So there is our magnitude defined, the angle of travel, tan inverse of the y component, sine 20 sine 10 over 15 cos 20 minus 5 cos 10. There we go. So therefore, it is traveling at magnitude of relative velocity, and that's from above. In the direction so I already decided it's going to be going east, whatever my angle was, north. So there we are. Two examples with velocity and using relative velocity. The second one, you're just looking for a resultant. So there's the homework. This kind of spans over a couple of days, remember. If you have any questions, you know where to find me. And good luck.